So we are starting a unit on rational functions, and the first like 2/3 of the unit are just on how to work with the rational expressions. So how do you add them, how do you multiply them, how do you divide them, how do you subtract them, how do you simplify them, all the different things with that. When I say rational, a rational number, if you guys remember, is a fraction, or a whole number that can be written as a fraction. So when we talk about dealing with rational expressions, we're talking about something that's going to be written as a fraction pretty much always, okay? So when you get a rational expression, the first thing you're going to do is you're going to rewrite the problem as a fraction. So sometimes, if you look at the notes, sometimes they'll give you the problem the way that it looks, so it looks like a fraction, but sometimes they'll write it as a division problem, and you just have to turn it into a fraction instead, as like your first step. After that, our second step is going to be to put the terms in descending order, so to make sure that your highest exponents go first, and then you have the exponents going from highest to lowest. The next step is going to be to factor, which is why we practiced factoring before we did this, because every single problem is going to have a factoring step. So one thing to keep in mind, and if you have a color with you, I would like highlight this. If you have a negative in the front, you're always going to factor out the negative, and it's really common for that to happen, and a lot of students miss that and then have a hard time factoring. So if you put it in descending order and the very first term is negative, you're going to have to take out a -1, okay? The other types of factoring are GCF, difference of squares, diamond, or slide divide, right? So I'll go ahead and put, and when I say diamond, all I mean is that X thing. So slide divide. So it's not saying that every single one of these factoring methods is used every time, but this is kind of your list to check, okay? After you have the factored form, then you're going to reduce the factors that are in common. So anything on the top and the bottom that is exactly the same, we know that when division, if you have like 5 divided by 5, that's 1. X plus 2 divided by X plus 2 is 1. 50x divided by 50x is 1. So what we're going to do is we're going to look for those pairs where the top and the bottom are the exact same thing, because we can cancel them out, okay? And then at the very end, we're going to have the simplified form, and the step 5 is like our goal to get to every single time, okay? So I would say the hardest step is this part right here, is factoring things correctly. Some students will try to reduce things before they factor, and that's how you kill a puppy, okay? By the end of this unit, we will have lots of dead puppies, because that is like the most common, that is the most common dead baby animal of all time. And this is the unit where it happens the most, okay? All right, so let's look at example 1. Example 1 should be a little bit of a throwback. It's not Thursday, but I think you've done problems like this before when you were doing things with exponents, when you had your negative exponents and positive exponents and stuff like that. So what we're going to do first is we're just going to look at the 18 and the 24. Is there a number that you could divide out of the top and the bottom? 6. Yeah, so you could divide out 3, but a bigger GCF would be 6. So I'm going to say top divided by 6 is 3, bottom divided by 6 is 4. So I can simplify that a little bit. If the top has x to the third and the bottom has x to the second, how could we simplify that? It'd just be x, and would the x stay on the top or would it be on the bottom? It'd be on the top because there were more x's on the top. So we would say x squared on the bottom is going to cancel with 2 x's on the top and leave 1 left over. And so that means on the top we have a coefficient of 3 left over, we have an x to the first power, and then on the bottom we have a 4, and we are done simplifying. So on this one, we kind of got to skip steps 2 and 3 because there wasn't really a descending order to put, it was just one term. And then there wasn't really factoring to do because it was just one term. So at that point we just reduced it, and then step 5 is this, the answer. It's where we have that reduced form. Okay. If you look at example 2, this one, they have done steps 1, 2, and 3 for you. They had it in the correct order, they had it written as a fraction, they factored it for you, and now you just have to decide what can cancel. So I'm going to say that x divided by x makes 1. but 7 does not divide by 3. I can't reduce that fraction. X minus 1 and x minus 2 cannot cancel at all because those are not the same factor. They do not divide to make 1. So we would say that our final answer is 7x minus 1 over 3x minus 2. If you want to distribute the 7 and distribute the 3, you can, but most people would not. Okay? I would not count you wrong if you did. If you did it, you'd still get full points. Okay? But if you were doing a multiple choice problem, the multiple choice answer is the one that we would get here. Okay? Now, some students would be like, Miss Rice, shouldn't these x's cancel? And the answer is no. That's how a baby puppy. That's how a puppy dies. And the reason for that is because x minus 1 is a subtraction problem, right? X minus 2, that's a subtraction problem. And subtraction and division don't cancel. So if you cancel out those x's, you're trying to tell me that a subtraction problem and a division problem should cancel, and they don't. Okay? The reason the other x is canceled is because this was 7 times x, and that x was being multiplied by something. And the bottom was 3 times x, and that x was being multiplied by something. And so we were truly canceling multiplication and division. That's why that one worked. Okay? All right, so let's look at the next one. What do we have to do first on example 3? Step 1. Yeah, write it like a fraction. So we've got x squared plus 9x plus 20 divided by x squared plus 13x plus 40. Can I cancel these x squareds right here? Think about it. It says x squared plus something, x squared plus something. No, you would kill a puppy if you canceled these, because this is an addition problem, and this is an addition problem, and addition and division do not cancel. Does that make sense? So we can't start with step 1. If you tried to cancel these, the x squareds, you would be going straight from step 1 to step 4, and you would be completely skipping step 2 and step 3. In step 3, the factoring is the most important step. The reason that factoring is the most important step is because when you factor, you're saying one thing times another thing. So when you factor it, you're getting it to be written as a multiplication problem, and then you can cancel the tops and the bottoms, because then you're saying multiplication and division cancel, okay? If you cancel right now, you're telling me that addition and division cancel, and we know that's not true, right? So if you cancel these right now, you're going to kill a puppy. Does that make sense? Yes, Ms. Rice? Marvelous. All right, so we are going to find what multiplies to 20 that adds to 9. Yeah, Jason? 4 and 5. And then we're going to look at what multiplies to 40 but adds to 13. 5 and 8. Okay. So on the top, we have x plus 4 times x plus 5. On the bottom, we have x plus 5 and x plus 8. And what do you guys see? Yeah, these are going to divide to be 1. X plus 5 divided by x plus 5 is 1. So I can say those cancel. And then my result is x plus 4 over x plus 8. Can I cancel the x's? No, that would kill a puppy, because that's addition divided by addition. And addition and division do not cancel. You could not, because reducing the 4 over 8 would be killing the same puppy for the same reason. So 4 over 8, that's an addition problem and an addition problem, and you can't simplify those using division. The next page is on top of the blue box. All right, for the next problem, example 4, what do we have to do? Yeah, write it as a division problem. So I have negative 6x plus x to the third divided by x squared plus x. What do I have to do next? I have to put it in descending order. So the top is written in an incorrect order. I have to put the x to the third first, and the negative 6x squared. Sorry, not squared, but the minus 6x goes second. And then I have x squared plus x. So when you change the order, you just have to make sure that the sign in front of the term stays the same sign. So since this was a positive plus x to the third, then I made it a positive x to the third. Since this said negative 6x, I wrote minus 6x. I'm just keeping them there. Okay, so we did step 1, we did step 2. What do we have to do now? GCF, we have to factor, right? So what's the GCF on the top? X. Oh yeah, it was x. And then you would get... And then what about the bottom?
It would also be x.
And what would you get left over?
You get just x. Wouldn't you get just
X plus 1. So if we think about distributing that out, x times x is x squared, x times 1 is x. And so we have that GCF of x, we have x plus 1. Okay, and then do we see anything that would divide to make 1? Those ones divide to make 1. So when you have a GCF in the front, those are nice. Those cancel pretty easily. When you have a factor in parentheses, the only way for a factor in parentheses to go away is for it to have the exact same parentheses on top and bottom. If the parentheses are not exactly the same, you can't cancel. Okay, so over here, when we have those parentheses, x squared minus 6 and x plus 1, those are not identical, so nothing about them can cancel. If you tried to cancel any part of it, you would be killing a puppy. All right, so for example 5, it is written as a fraction. It is written in decreasing order already, or in descending order. So what do we do next? Okay, so is there a GCF on the top? No. Yeah, but it's not GCF. What's the method called? Difference of squares. So we would say 2 sets of parentheses, one with a plus, one with a minus. On the bottom, this is the part I was talking about, you have a negative in the front. So how do we handle that if you have a negative in the front? So we took the negative out as like a GCF of -1, and then we divided each term by a negative. So negative x divided by negative is positive x, positive 4 divided by negative is -4. And then these cancel to make a 1. X minus 4 divided by x minus 4 is 1. So we have x plus 4 divided by -1, and this answer does not need to stay as a fraction. So negative x minus 4. So that's an answer. You will see some people, when they see a negative on the bottom of a fraction, they just move it to the front and put it in front of parentheses. So you might also see it as negative of x plus 4. These are both good answers. They both get full credit. Okay. All right. Example 6. What do you guys notice? Yeah, the top is not in order, so we have x squared comes first. Then what? Okay, then what? All right, and then on the bottom we have x squared minus 2x minus 15. Do we cancel the x squareds? Nope, that would kill a puppy. Good catch. So what do we do? Step 1 is done, step 2 is done. We do diamond, we got a factor. So we're looking for 2 things that multiply to -5 but add to -4. -5 and 1. And then we're looking for 2 things that multiply to -15 but add to -2. Okay, and then what do we see? Those canceled, they divide to make a 1. And then we have x plus 1 over x plus 3. And we are done. We cannot cancel those because the parentheses are not identical. Okay, before we do the next part, I need you to go in the back and grab a marker or a colored pencil and then come and sit back down. So I've got colors back there, grab a marker or a colored pencil and then come sit back down. All right, so in the other color, there's not a lot of space for this. I would go ahead and maybe write it right here, but write kind of small. When you guys were in Math 2 and you were dealing with radical functions, you learned that you can't square root a negative, right? And whenever you would solve a radical equation, you'd have to take your answer and you'd have to plug it back into the equation and make sure you weren't square rooting a negative, right? So when we do these problems, we have to make sure that we're not dividing by 0, because that's a rule that you have with fractions, right? You can't divide by 0. So we have something, it's called an excluded value. Is that term familiar? Have you guys heard of that before? An excluded value? Yes? No? An excluded value is a value that makes the expression undefined. So I can have 5 divided by 1, I can have 5 divided by negative 13, I can have 5 divided by 1,000,000, but I can't have 5 divided by 0. I'm not allowed to divide by 0 ever, okay? And since these are all written as division, it's a fraction with a top and a bottom, and you're always dividing by something, we have to determine what's the one thing you can't divide by. And it's whatever you would plug in for the variable that would make the denominator equal 0. Okay, so if you look at example 1, the only number that you could plug in for x that would 0 out the denominator is 0. So I'm going to say x cannot equal 0. So this is called a monomial, right? If you have one term, it's a monomial. If you have 2 terms, that's a binomial. If you have 3 terms, that's a trinomial. So we have a monomial here, so there's only one value we can't have. Over here, the bottom would be considered a binomial. If we were to FOIL out the bottom or multiply out the bottom, it would have had 2 terms. So for the 3x, I can see that the x canceled, but it's still an excluded value. So for the 3x, I'm going to say x cannot equal 0 because that would 0 out the denominator. If I plug a 2 into that factor, that would 0 out the denominator. So those are my 2 excluded values. So can't have 0, can't have 2. If I look at this problem, in the denominator I have an x plus 5 and an x plus 8. So x cannot equal negative 5, x cannot equal negative 8. So you can't have negative 5 because it would make that first parenthesis 0 out. You can't have negative 8 because it would make the second parenthesis 0 out. So notice I'm not looking at the parentheses on the top, I'm looking at the parentheses on the bottom. I just don't want the bottom to equal 0. Okay. If we look at this one in the denominator, I have that x in the front, so the first one I'm going to say x cannot equal 0 because of that x in the front. For this one I'm going to say x cannot equal negative 1 because that would make that parenthesis go to 0. So x cannot equal 0, x cannot equal negative 1. Okay. For example 5, we had x minus 4 in parentheses. If you look at the GCF, it didn't have an x in it. It just had a negative. So that does not contribute to the excluded values. For this one, I would say the only excluded value I have is that x cannot equal positive 4. And then for number 6, if we look at our denominator, we have two different factors. So x cannot equal positive 5, and x cannot equal negative 3. So the excluded values are found from the factored form before the canceling happens. From the factored form before the canceling happens. Okay, so what do I need to do to look for an excluded value? What do I need to do to look for an excluded value? It comes from the denominator. What do you look at in the denominator?
At the values before you like cancel everything, and then you just write down the opposite of those.
So you're looking at your factors, the factors on the bottom, and then you say it can't equal the opposite sign, okay? And that's because the opposite sign is what would make it 0. A positive 5 and a negative 5 make 0, so you want to make sure there's no zeros on the bottoms. Not for every single problem, but for some of them, yeah. Okay. The reason that we don't care if the top equals 0 is because if you do 0 divided by 5, your answer is just 0. So we're okay with getting 0 as an answer. We're just not okay dividing by 0 because you're not allowed to do that.